Hey, this is Evan at Serra Laser, and I'm going to talk to you a little bit about the LightBOT. The LightBOT is the Fanuc CRX collaborative robot hooked up with the IPG LightWELD 1500 laser welding systems. There's a couple different versions of the Fanuc, different sizes. The one that we're using here with the demo that you saw is a CRX 10IA. Over here we have the largest one, which is the CRX 25IA. This has a 25 kilogram payload, and yeah, it's really nice. It's a really massive unit. But yeah, so what I'm going to go over with you is kind of what was going on during that program of the rotary part. You can see here, combining the laser welder from IPG with the Fanuc collaborative robot is really going to yield extremely consistent welding results. So we have a really nice finish up here on this flange joint. And just to give you reference, I'm going to show you what it looks like before we weld it. So these were just hand tacked into place. They are laser cut parts, so the repeatability was really nice. So I'm going to show you this program. Most of the time what I'm going to do when I start off with my program is I'm going to set my welding parameters. So with LightWELD, we are going to choose a preset mode to start with, or a custom mode. In this case we used a preset mode for fusion welding of stainless steel. So this icon here is the set program icon. We've chosen a 1, and then we've decided to override the power and add an additional bit of wobble width. So this is going to get our laser set up correctly, and the Fanuc controller is going to send the information necessary directly to the LightWELD in order to get that information in there. The next icon is going to be some positional data. This happens to be our home position icon. That's where the robot's going to go, or it's going to start the program and it's going to finish the program at that position. As you can see, we have some positional data captured here, and if we need to make an edit to that, we can either directly edit it in this area here, or we can move the robot where we want it to be by using the robot operations menu. We can teach it by hand, or we can jog it in very accurate increments. And then we can touch up that position to recapture that point if we needed to make an adjustment there. So there's a few more positional data points on the way to our weld position. And because we are fusion welding at this moment, we are going to use a force contouring action. Pieces like this, round pipe, may appear to be perfectly round, but they almost never are. And so to maintain contact with the part during the weld, which is something that we'll do with this LightWELD system, we will use the force contouring feature. So the force contouring feature is going to maintain a set amount of force in a predetermined direction over the course of our next action, which happens to be a weld. So by dragging this icon, force contouring start, it allows us to choose which tool we're using, which direction we would like to push, and the amount of force that we're going to be pushing with. There's also a few other options down here. One thing that's important is we want to make sure that we don't start the next motion until after contact. So it's going to make sure it senses that amount of force before moving on. After that, we have the laser on command. Now the laser on command is going to do a sequence with the triggers on the LightWELD handheld welding gun and start the laser firing. So we have a couple of adjustments here: gas pre-flow and power ramp up, that we can adjust independently of the actual program which we had set previously. In this instance, we're using a rotary fixture to spin the tube. So we have that hooked up to a digital output, which we have set up with a relay, and we are just calling up an output. We've set it to digital output. We could also do analog output if there was a voltage that we would need to apply. and we have it set to on at that point. Then in our circumstance here, we've timed the rotation of our part and we've set a wait command so that it doesn't move on to the laser off until after this set time, which in our case here is 28.5 seconds. Then comes the laser off command, which will just terminate the laser beam. We also have some adjustments here, power ramp down and wire speed ramp down. We are not using the wire on this application, so that will not do anything. Then we have a small wait, which is going to be for our post flow. We're going to turn off the rotary, digital output 104 off. We're going to release the force contouring pressure, and then we're going to begin our movement away from that weld. And then next comes just another weld, which is the intermediate weld here between these two pipes. And in this instance, we've made a little bit of a change to the power. So we've dragged up the set power icon, set the power to 750 watts to get a little bit of extra penetration. We move to our position, force contour once again, laser on, and everything from there is the same as the previous. And then towards the end here, we have our return to pole position. So that's sort of how the layout of these programs goes. When you add the wire feed, it's going to automatically change the way it does things when you select the wire feed to be activated. Thank you.